everyone. Today we are going to learn some MCQs which was asked in previous year UPRVUNL AE question. So this is one of the state government exam questions. Okay, yeah. Okay, let's get started. Let's see the first question. A clamper circuit adds and subtracts a DC voltage to or from a waveform. We have to select the correct statement here. Okay. What first option is adds and subtracts a DC voltage to form a waveform and does not change the shape of the waveform and amplify the waveform. What's the wrong statement here was 3 because it doesn't amplify the waveform. Okay, it doesn't change the shape. The shape will be same, and it adds or subtract the DC waveform from the center axis x-axis. So the option 1 and 2 is right. So option 1 is the right answer. Okay, the next one. De Morgan's first theorem shows the equivalence of, okay, we all know De Morgan's theorem, but specifically they asked De Morgan's first theorem. What was that? Was a plus b the whole bar equal to a bar dot b bar. It is in the word format, right? A plus b the whole bar is NOR gate, and the bubbled AND gate was NAND gate. Okay, so the option is second, NOR gate and the bubbled AND gate. What was the expression? Was a plus b the whole bar equal to a bar dot b bar. Okay, the next one. When a waveform voltage is applied, the direction of electric field is always from. Okay, so when a voltage is applied, the direction of electric field is always from positive to negative. Someone confused between negative to positive. Okay, let's see the properties of electric field. Electric field line starts from a positive charge and ends at negative charge. Okay, the number of field lines are directly proportional to the magnitude of the charge. Okay, the magnetic field lines never intersect. They are perpendicular to the surface charges. These are the another points. Okay, so the electric field line starts from positive charge and ends at negative charge. So this is the right one. Okay, the next question. Why interpoles are used in DC machines? Okay, interpoles are used in two purposes, like in armature reaction and commutation process. Okay, what the options was that to counteract the reactance voltage, it's just right. To counteract the demagnetizing effect of armature MF in the commutating zone, and the third one, to counteract the magnetizing effect of armature MF in the commutating zone to convert DC EMF to AC work. It's wrong option. Okay, we confuse between these three options. Why is the right one, and it is also used for the armature reaction process also. Okay, but what armature reaction was? Cross magnetizing effect. The interpoles are used to reduce the cross magnetizing effect, not demagnetizing, not magnetizing. So option is correct, was to counteract reactance voltage. Okay, let's see the explanation. The automatic utilization of cross magnetization due to armature reaction. DC machine is basically two functions. One is neutralization of cross magnetization due to armature reaction, and to counter and cancel reactance voltage in coil undergoing commutation. Okay, the next one. Which of the following DC motors value power? Which of the following DC motors the value of power drawn remains same at different loads? Power remains same at different loads. Which type of motor is correct? Cumulative, differential, series, shunt. That's the answer. What is that? Was series, because the DC series motor torque and speed is inversely proportional. That means T and N equal to constant. That is, the load is constant. Okay, torque into speed is called power. Okay, so the load power is constant. So the option is 3, series motor. Okay, the series motor used to maintain the power remains same at different loads. Okay, the next one. Given that the starting torque of 3-phase induction motor is 3 times of the rated current, while the rating slip is 6%, what would be the ratio of starting torque to full load torque? Which is a question asked from induction motors. We all know it's a familiar formula which is always asked in ESC. Okay, so what was that? Was starting torque to full load torque equal to slip of full load slip at full load into starting torque to full load torque the whole square. They ask starting torque to full load torque ratio, and what they given was slip torque and starting torque to full time current. This 3 times. Okay, so multiply 3 square into 0.06, we get the answer. Okay, so 0.54 is the right one. Okay, next question. Identify the correct incorrect statement regarding the power Mosfet. Okay, we have to select the incorrect statement. Okay, what's the first one was, these are so constructed as to avoid punch through. So it's the right answer. Okay, the next one, the channel length is relatively large and the channel width is relatively small. It's a wrong one. Okay, and let's see third option. They do not experience any minority charge carrier. It's the right one. They can be put in parallel to handle large current. It's also a right one. Okay, this is the wrong answer. So what the correct one was, the channel length is relatively small and the channel width is large. There the option is they given was inverse, so it's a right, it's a wrong one. Okay. Okay, next question. Why does an ACR fail to return off even when it is conducting mode and a reverse voltage is applied between anode and cathode? Okay, why does ACR fail to turn off? Okay, what does mean by turn off current? Below this current it will be turn off. Okay, so let's see the answer. Let's see the option. First one, positive voltage is applied to the gate and the reverse voltage is small and the anode current is more than the holding current and the turn off time of SCR is large. Guess the answer. What's the right answer was, the anode current is more than the holding current. Okay, holding current is the turn off current. Below this current the SCR will be turn off. For if it is failed to turn off means the anode current must be more than the holding current. So the third one is the right answer. So, okay, so the anode current is greater than the holding current, the SCR failed to turn off. Okay, the next one. A 240 volt 50 Hz supply feeds a high inductive load of 50 ohm resistance at a firing angle 45 degree. What would be the value of load power when the supply is through the resistor of full control bridge? Okay, the question seems like very long, but the answer is very simple. What they given was voltage, frequency and the inductive load. But an angle, firing angle is 45 degree and the ohm resistance is 50 ohm. Okay, we have to find the value of load power when the supply is through the thyristor full bridge. Okay, it's a full bridge converter. Okay, what is the formula of full bridge converter? The average voltage is V0 equal to 2 Vm by pi cos alpha. Then they asked the power, so we have to find the answer of I0. I0 means V0 by R. They given the R value, so find I0 and V0. Firing angle is also given, so then find the power. They given the constant load current, so IRMS equal to I0. Okay, so P0 equal to the load power equal to IRMS the whole square into R. Okay, it's a very simple question. Okay, let's substitute all the values and we find the answer. Okay, so the answer correct was, what was that, 466 watt. Okay, the next one. A DC to DC chopper operates at 448 volt source with a resistive load of 24 ohm. If the chopper frequency is 250 Hz, what will be the value of RMS current when T on is 3 millisecond? Okay, what they given was voltage and the resistance and the chopper frequency and tan on time. Okay, from this you have to find the RMS current. Okay, RMS current, we have to find the RMS current. That's the formula of RMS current. What was that was, IRMS equal to root del Vs by R. Okay, we have to find the del means T on by T. Okay, they give T value and they give the total frequency, chopping frequency. Okay, 1 by F is T. So from this we can find the del and root del into Vs. They given Vs value 48. Then root del Vs divided by R. Then find the RMS load current. Okay, that's what this the way we have to do this question. It's a very simple question. Okay. Okay, what's the answer? 1.732. Okay, the next one. A transfer function h of s of a system is given as h of s equal to 3s squared minus 2 divided by s squared plus 3s plus 2. Determine the step response of the system. You have to find the step response. Okay, how we solve the question was, first write the transfer function. It's a transfer function. What was that? Y of s divided by x of s. Okay, so h of s equal to y of s divided by x of s. Then you have to find the step response value. Then x of s equal to 1 by s. Okay, the substitute 1 by s, then apply partial fraction method. These are the separate roots. 3 roots are there, so a by s, b by s plus 1, c by s plus 2, and cross multiply all the things and put the values of individual poles. A is equal to 0, a is equal to minus 1, s is equal to minus 2. We get the a, b, c value. Then take the inverse Laplace transform and we get the answer. What is that was 5 e power minus 2t minus e power minus t minus 1. Okay, the C is the right answer. Okay, that's all about today. Thank you friends, thank you for valuable time. If you have any doubts in this question, please write it down in the comments below. Okay, thank you so much.